In this video, we'll be going over LeetCode problem 12, integer to Roman. Here's the problem description. Roman numerals are represented by 7 different symbols: I, V, X, L, C, D, and M. Here's a table with the respective symbols and their values. For example, 2 is written as II in Roman numeral, just 2 ones added together. 12 is written as XII, which is simply X, 10, plus II, 2. The number 27 is written as XXVII, which is XX, 20, plus V, 5, plus II, 2. Roman numerals are usually written largest to smallest from left to right. However, the numeral for 4 is not III. Instead, the number 4 is written as IV. Because the 1 is before the 5, we subtract it, making 4. Same principle applies to the number 9, which is written as IX. They told us that there are 6 instances where subtraction is used. I can be placed before V, 5, and X, 10, to make 4 and 9. X can be placed before L, 50, and C, 100, to make 40 and 90. And C can be placed before D, 500, and M, 1000, to make 400 and 900. So here are some examples. So the number 3, if we want to write the number 3 in Roman numerals, our output should be the string III. If our initial number is 58, our output string should be LVII, where L is equal to 50, V is equal to 5, and III equals 3. And then finally, if our number is 1994, our final output should be MCM XCIV, where M is 1000, CM is 900, XC is 90, and IV is equal to 4. So let's take a look at these examples in a little bit more detail. Here we have the number 58. And I've listed here the entire table of all of the different symbols and their values. So the question here is, how do we break down 58 into a Roman numeral string? Now, here it might be easy to see, okay, we have a 50, so we have this 50 over here, and we can grab this 50, and that would give us, I'll write the string up here, L, and then we can see, okay, now we have to make this 8, so maybe we'll grab this 5, and we'll add that, so that's a V, so we grab that, and then we'll grab some 1s. So 3 I's. Now, it's pretty easy to see this for this one number, but we want to think of a systematic approach for how to deal with any number. So let's just erase this for a second and take a look at how we might do that. So one option you might think of is maybe we can just start with the smallest number over here and start to build it up, and then we'll move on to this 50 over here. So in this case, we're going to start by trying to build up an 8, and we might go here and say, okay, let's look at what values we have. And we say, okay, we see that we have I equaling 1, a value of 1. 8 can be made up of 8 ones, so you might think, okay, let's just add 8 I's over here. And that takes care of this 8, great, so then all we have to do is get this 50. So we would look down here, maybe we'll take this L and get something like that. Unfortunately, this is incorrect. And the reason this is incorrect is we always want to try and use the largest possible value, or the symbol for the largest possible value, to decompose a number so that we can make the number as condensed as possible. And so here's the way to look at this. Let me erase all of this. If we're trying to build a number like 58, what we want to do is we want to actually start at the bottom of our symbol table and find which value can we put into 58 that fits and that is the largest possible value. So if we do that, we can start with this 1,000. We see that 1,000 doesn't fit into 58, so we'll skip it. Then we'll go to 900. 900 doesn't fit into 58, we'll skip it. We'll skip 500, 400, 100, 90, and then we get to 50. And all of a sudden we see 50 does indeed fit into 58. So what we'll do here is we'll say, okay, we've used our 50. 50 here we can see is corresponding to L, so let's add our L, and then we keep going. So now we can keep going, say, okay, we've used this 50, this L, why don't we see this 40 fit? Now, here's where it kind of becomes a little bit more interesting. This 40 technically does fit into 58 because 40 is less than 58. The thing is, we already said we were going to use this 50 over here to build up our 58. So what we need to make sure to do is as we build up this number, we need to subtract anything we've already used. So in this case, we want to subtract the 50, and now we just try to build up the remaining. So now all we have left to build up is 8. So now our new number, in a way we can think of it, our new number is no longer are we looking at this 58, we're now just looking at this 8 over here. So let's keep going now that we know we're looking at 8. So if we look at 8, let's see, does 10 fit? No, it doesn't, so we'll skip it. Does 9 fit? No, it doesn't, so we'll skip it. Now the question is, does 5 fit? 5 is indeed less than 8, so 5 does fit. So we're going to use that. So we're going to add our V up here. And then again, we need to subtract 5 to indicate that we've used this 5. So if we subtract 5, we will get a total here of 3. So now we have 3 left, and then we keep going. So let's keep going. Does 4 fit into 3? No, it doesn't. And then all we have left is, does 1 fit into 3? Yes, it does. We're actually going to need 3 1s. And so then we can add our 3 1s over here. And now we know that we can actually, let's do this in blue, subtract a 3. And now we kind of have finished our number. So there's nothing left. So this is going to be our final answer here. So let's take a look at another example. We're going to follow the same process and see how it works. So in this example, we're looking at the number 1994. So again, we're going to follow the same approach. Start down here. Start with 1,000. Does 1,000 fit in 1,994? Yes, it does. 1,000 is less than 1,994. So again, what we need to do, say, okay, we're going to use this 1,000. So what we need to do is we need to make sure we subtract out the 1,000 that we used. So let's do this like that. I'm going to do that in blue. And our new number now becomes 994. And because we use this 1,000, we want to just note that we use this M. So let's put this M up here, and then we keep going. So let's keep going. Now we check, does 900 fit inside of 994? Because remember, this is our new number we're looking at. And yes, 900 does fit. So we're going to use this 900. So I'll write it down here, 900. And then what we're going to want to do, again, subtract. So that's going to give us 94. And so now we can indicate that we have used the CM. So we'll write CM up here. And then let's keep going. So now we have 94 as the value we need to build up. So let's see, does 500 fit into 94? No, it doesn't. Does 400? No, it doesn't. Does 100? No, it doesn't. How about 90? Yes, 90 does fit inside of 94. So what we'll do here is we're going to, again, just subtract 90 to indicate that we used this 90 over here. And so now that we've subtracted 90, see, running out of space a little bit. Now that we've subtracted this 90 over here, we want to indicate that we use this XC. So let's add this back. And this is going to give us a value of 4. So now our new value we're looking at is this 4 over here. And then we just repeat the same process. Does 50 fit inside of 4? No, it doesn't. Does 40 fit inside of 4? No, it doesn't. Neither does 10, neither does 9, neither does 5, but 4 does indeed fit inside of 4. And so our final answer here is we're going to use this IV, and our final answer will be this. So that's the process of actually moving through. So again, just to reiterate, what we want to do is we want to start with our original number, so in this case 1994, and then we want to move from the bottom of our table all the way to the top and find the biggest numbers that can fit. So let's take a look at how we might code this up. So I'll be coding this in C++, and let's start by actually building up some sort of table to allow us to do this access and to actually check the different values in their symbols. Now, one clever way of doing this is we can actually use two vectors in order to store the entire table. And so what I'll do here is I'll start by actually storing let's change that, a vector of ints. I'm going to call it values. And what I could do here is I could indeed just store the values kind of starting at the bottom. So I could do 1, then 5, then 10, then 50. I could do that. But there are two things we want to remember. One, it's going to make our life a lot easier if we also store these additional values that have special symbols inside of our table. So that's going to be the first thing. The second thing that's going to make our life a little bit easier is if we actually store the values in reverse order. Given we need to iterate from quote unquote the bottom of the table to the top, it might make sense to store the largest values first. So that would look as follows. So instead of starting with 1 and then going to 5, 10, and 50, let's start with 1,000. And then let's move to our next value. Our next value in this case is actually going to be 900. And then we'll go to 500 from our original table, then 400, then 100, then 90, then 50, 40, 10, 5, oh, this one, 9, 5, 4. And lastly, 1. So now we have all our values here. And then the next thing we want to do is we actually want to create another vector. This time it's going to store strings, which are going to be the symbols, the corresponding symbols here. So that'll be M, and then we'll have, let's see what's next, CM, and then D, CD, C, and then 90 is XC, keep forgetting to put these in quotes, XC, then we have, let's see, we've done XC, so L, then XL, then that gives us, so XL, then we need to do X. See, I'll just take out these extra spaces. Then we have X, and that will be 10, so now we need just 9, so that's going to be IX, then V, then IV, and finally just I. So now we essentially have recreated our table using two vectors. So all of our values are now here, so add this in quotes, and all that's left for us to do is to implement this. So what we want to do is we want to follow the same approach. So remember what we said we would do is we're going to actually go through our values and try to find the first one that fits inside of num. So I will just iterate through I less than, and this is going to be values.size, and then I++. So iterate through this entire vector. And then what we want to do is we want to check if the value here, which is going to be values at I, is less than num, which is our original value that we're trying to convert, then we actually have found something and we need to append to our string. So what we can do is let's actually declare our output string. So I'm just going to call it output, and we can have it as an empty string to start out. So if values is less than num, we're going to want to append to our output string. So we know that the value is going to fit inside of num, but the next question is how many times? How many times does, say, 1,000 fit inside of 3,000? So what we're going to want to do is I'm going to call this repeats. So we're going to calculate repeats by dividing num by whatever values at I is. So values at I in this case. So it's going to tell us the number of times we need to repeat the symbol. So now that we've done that, what we can do is we can actually call this one J, repeat the symbol the given number of times. So J is less than repeats, and then J++. And now all we need to do is we need to append to our output string. Each time we just want to append whatever symbols at I is. So symbols at I. So what this is saying is, let's say our number is right now 3,000. We see that 1,000 fits into 3,000. So then we want to, and we see that it fits in 3 times, so that this int repeats. And so we want to append 3 m's to our output string. Once we've done that, so once we've kind of repeated or appended our repeated symbol, what we want to do is, again, we want to indicate that we've actually used a value, and so we want to subtract from num. So what we want to do is we'll want to do something like this, num equals, or num minus equals, and here what we're going to do is just repeats times values at I. And we'll keep doing this, and this process should return what we're looking for. Let's see if we've missed anything. So here's our output string. We're going through each one. If values at I is less than, and we probably want to say less than or equal to num, then we want to figure out how many times it repeats, and then append the symbol that many number of times, and then just subtract however many kind of value, how much value we just added to our string, and then eventually we'll just return output. So let's submit this and see how it does. Awesome. Well, thanks everyone for watching, and feel free to comment if you have any questions.